Next, we want to look at a tournament, which is a series of rounds of the game. Let's think about how we might represent that. We've got plays from each player, so we're going to have essentially two lists of plays, and what we can do is represent those as a pair of lists here. So I'm showing the two sides in blue and brown, and you can see I'm building up the lists, adding the most recent scores to the front of the list. So what we have here, the tournament is represented by a pair of lists. We could also represent it as a list of pairs. So we'd have a list, each item would be a pair, which would be the two plays for the me and you, or the player and the adversary. So we would store it that way. Why might you think we build the lists backwards? Well, the answer is that what we're going to be doing is accumulating scores. So we're going to be, as we play, we're going to be adding pairs, adding items to these lists of plays. And we don't want to be adding items at the end of a list, because as we discussed when we talked about the reverse function, that will turn out to be a quadratic process. The longer the list gets, the more time it takes to add an element to the end of that list. And in the end, adding an element is linear in the length of the list when it's at the end, and so the whole process becomes quadratic. So we build the lists putting the most recent elements at the front. Now there's a question, do we want to build this as a pair of list or a list of pairs? We can do either. I suppose one marginal argument for the list of pairs is that we assure in that case that we have every move has a corresponding move by the opponent. In a pair of lists, it would be possible to have lists having different lengths, potentially. I don't know how that would happen, but the data type allows it, whereas the data type of a list of pairs doesn't allow that. So that would be one argument in favour of that. Now, taking the pair of lists approach, what is the result of a tournament? What we want the result is we get by adding up the scores for each move. So let's have a look, each round. So here we've defined the type of tournament as a pair of lists of moves, and the res takes a tournament and gives us an integer. When both lists are empty, we return the result 0. Otherwise, we take the first element of each of the lists, find the outcome of that, which remember will be a number 1, 0 or -1, and add it to the result of the remainder of the tournament. So we are going down the lists in lockstep, so it's like zip or zip with, except we have the two lists paired into a single pair. So that's one approach there. So we're doing if you like, a zip with, but in a form where the lists come together. If we think of the tournament, a tourno, as a list of pairs, we can get the result by using some standard functions. We can map along that list of pairs the function outp, which is just like outcome, but it takes its two arguments as a pair. So outp takes a pair, takes the two components of the pair and separately passes them to outcome, which we defined earlier. So we map that function along the list. So for each pair we get a result 0, 1 or -1, and then we take the sum of that list, and that gives us our result. So again, I guess an advantage here is we're using some standard functions. And in fact, we can move. It's not difficult to convert from a tournament to a tourno and back. And I'll leave that as a small exercise for you. So now we've got to the stage where we can take a tournament, find out who has won. So we've got as it were, the back end that will allow us, once we've got the plays from both players, to say who has won a tournament. But next we want to think about how we might automate the play by the machine.